Hello everyone. So this is the second lecture on light. Okay. On the first lecture we discussed about the light and reflection of light, laws of reflection. Now today we will discuss about the reflection in mirror. This is that about the application of concept of reflection. Because see, our final objective will be to analyze the image formation in mirror. So before that we have to understand the reflection part in the mirror, because what is an image? Okay, image is nothing but the intersection point of reflected rays. Okay, image formation is nothing but the intersection point of the reflection rays. Okay, if you understand, if you can find the intersection point of the reflected rays, then you can find the image. Okay, but to find that intersection point of the reflected rays, you need to understand the path. Okay, path through which reflected ray will travel. Okay, for the given incident ray, what will be the path of the reflected ray? So that is this is the particular objective of this lecture. Okay, so let us have a discussion. So before discussing about the reflection in mirror, let us first discuss about the reflecting surface of a mirror. Okay, so that this is the mirror, and light is coming from this side. What is the surface? Okay, this is the surface. If this surface is whether the surface is plane, or if you see so this is the reflecting surface of mirror. Okay, this is the reflecting surface of mirror. See that if the I have one. If the surface is plane, then that is the plane mirror, or if the surface is curved in nature, then that is spherical mirror. So there are two types of spherical mirror, one is concave and convex. We will discuss in detail. So this is the concave. Okay, that is the surface. This surface is curved surface is going towards the light, and this is going away from the light. We will discuss. Okay, so before we discuss about details about the spherical mirror, let us have a discussion about the reflection in plane mirror. Okay, in the reflection in a plane mirror, the reflected ray in a plane mirror. So this is the plane mirror, this is the plane surface, and this will be normal to the plane. That means this will be 90 degree. Okay, this will be 90 degree. Now this is the incident ray. If this is the incident ray, then there will be an angle, that is theta, angle of incident, that is theta I. Okay, now there will be a reflected ray, right? And according to the law of reflection, the reflection will make same angle with the normal, like the incident ray. That means there will be another angle theta I. Okay, another angle theta I, and reflected ray will make that angle. So this is also theta I. Okay, so this is the statement: the reflected ray returns back to the same medium with an angle of reflection same as the angle of incident. Now the same thing you can do for the spherical mirror. Let us have one thing, not here, this. Okay, let us have this is a spherical mirror. This is a spherical mirror. Now see, if incident light strikes here, then the normal here will be this one. If the incident light strikes here, this is the transient, and then normal to the surface will be then there will be another, the normal will be different, that will be not be parallel. So here, then this is the transient, and here this is the normal. Okay, so but in case of plane mirror, normal is always, all the normal are parallel, So the incident ray, you can easily analyze and understand how the reflected ray will be. But in case of plane mirror, analyzing and understanding at each point will be complex, not difficult, it will be complex. So it will be better if you understand some reflected ray for particular incident ray in case of spherical mirror. That we will discuss. Okay, so before going to a detailed discussion about the reflection in spherical mirror, let us have a discussion about the different type of spherical mirror. Okay, so there are two types of spherical mirror. So first, the spherical mirror. What is the spherical mirror? A spherical mirror is a curved mirror in which a part of the hollow sphere. It's a curved mirror which is a part of hollow sphere. And spherical mirror are two types: concave mirror and convex mirror. So what is concave mirror? Concave mirror is spherical mirror whose reflecting surface is curved inward, and the convex mirror, the reflecting surface is curved outward. If you see here, this is concave mirror and this is convex mirror. And remember, light always comes from left to right. So this is the light. So this is the light. Okay, light is coming from this side. This is source of light. Okay, this is source of light. Now see, this is the reflecting surface. This reflecting surface is going inward, means it is going towards the source. Okay, the reflecting surface, this curved surface is going inward. Okay, but in so you can see this one, so going inward, that's why it is. But in case of spherical mirror, if light is coming from this side, okay, so light is coming from this side. Okay, now this is the reflecting surface and going away from the source. The source is here. Okay, the source is here and the light is going away from the source. So going the reflecting surface or curved surface is going outward. So here you can see the reflecting surface is curved inward, and the in convex mirror the reflecting surface is curved outward. Next point, rays of light parallel to the principal axis after reflection from a concave mirror meet at a point on the principal axis, and remember this point, converge. Okay, converge. See, okay, see, okay, we'll discuss about the what is the principal axis. But principal axis is nothing but the, suppose, just to understand first, let us consider this is a circle. Okay, the circle, this is the center and this is the radius in diameter. Okay, so similarly, or this is the diameter and this is the radius. Okay, so similarly there will be the radius or diameter. You can say radius here. Okay, so that is called principal. That is the principal axis. So this is the principal axis, and these are incident rays. These are incident rays. Okay, all incident rays are parallel to each other. All incident rays are parallel to the principal axis, and after reflection, they will move towards each other. The reflected ray here, the reflected ray here, the reflected ray. These all reflected ray will move toward each other. So moving toward each other, here is the point converged. Okay, if you see, I have written converge. Okay, the reflected rays. Okay, in the concave mirror correspond to the incident ray parallel to the principal axis. Converge means moving towards each other. See this part, and meet at a point on the principal axis. So they converge. They all are moving towards each other. That means they are converged and meet at one point on the principal axis. Okay, so this is the case of concave mirror. But in convex mirror, what happens? Okay, the convex mirror, see, they are coming. They will move away from each other. That means they get diverged. Okay, this is the principal axis. These are incident rays. These are incident rays. Okay, now see this one, they get diverged. They are moving away from each other. But from the behind the mirror, if I extend the principal axis in this direction, okay, they will appear. They will come from the principal axis at one point. See, right? This appear like they are from on the principal axis behind the mirror. Okay, all the reflected rays are coming. Okay, so this is the point. Rays of light parallel to the principal axis after reflection from a concave mirror get diverged and appear to come from a point on the principal axis behind the mirror. Okay, so this is what is concave and convex mirror. Now we will discuss about the what you can say, some terms on the spherical mirror. Okay, let us have a discussion. Okay, so these terms will be useful to analyze the image formation both theoretically and numerically, mathematically. Okay, so you should understand what are these terms. One is the center of curvature. So center of curvature, like circle, that I have already told, like circle. Okay, there will be a center. Similarly, the sphere, there will be a center, that is C, and that is the and then there will be a radius from center to the point. This is the pole. Okay, this is the pole. What is the pole? Pole is the center of the spherical mirror. The spherical mirror, this is the center. So this is the center, and this is the center of the sphere, and this is the hollow sphere, and this is the center of the mirror. Okay, this is the center. This C is the center of the sphere, and this is the center of the mirror. Okay, so from here, C, center to pole, this distance is the radius of curvature. Okay, one thing remember, you have understand the xy graph. Okay, this is x-axis and this is y-axis. Okay, now what you, the whole mirror and lens, all those analysis will be done similar to the xy graph. Okay, that means this is the origin, this is the origin O. So here the origin is P. Okay, here the origin is, this is the origin. Okay, and whatever the distance, we'll discuss later. Whatever the distance you will measure on the left side will be negative, and whatever the distance you will measure on the right hand side, it will be positive, and whatever the height you will measure on the upward direction will be positive, and whatever the height you will measure in the downward direction will be negative. We will discuss in detail. So the distance, this is the origin. So all the distance will be measured from here. So that means the distance between center and the pole is the center of curvature, and the radius of curvature. And then we have already discussed about the focus. Okay, what is the focus? Now all this parallel line, okay, all this parallel incident line after reflection meet at one point. This is the incident line parallel to the principal axis. Incident line parallel to the principal axis reflect towards each other and meet at a point on the principal axis. That is the focus. What is the principal axis? The principal axis is the line, okay, connecting the center of curvature and the pole. If you see, principal axis is the straight line passing through the center of curvature and the pole, and principal focus, that point we have already discussed. And what is the focal length? From the distance from focus to the pole, because all the distance will be measured from the pole. Okay, so this is denoted as F, or this is denoted as R, and remember R is equal to twice the value of F. R is equal to twice the value of F. Okay, now so R is the value of F. So focal length, this is the focal length. Focal length, what is focal length? Now the distance between the focus and the pole. Okay, now we understand the terms using mirror. Another point I will talk about. See, all the center of curvature, focus, and the principal axis. Okay, so we remove all this. The center, focus, and the pole are on the front of the mirror. This is the mirror and this is the front. Okay, this is the front. So are on the left side of the mirror or front of the mirror. But in case of convex mirror, in case of convex mirror, okay, all those points, this is the front of the mirror. This is the front. Okay, this is the front, this is behind. But in case of convex mirror, the center of curvature and focus will be behind the mirror. Okay, will be behind the mirror. Remember this basic, that center of curvature, focus are in front of the mirror, but in case of concave mirror, but in case of convex, it will be behind the mirror. Okay. Now, now you reflection by spherical mirror. So remember what is the image formation I have discussed. Image formation is nothing but the intersection of reflected light. Okay, intersection of reflected rays or reflected light. So remember, all those reflected rays meet at one point. All those reflected rays meet at one point. Okay, that means if I have two reflected rays, if I have two reflected rays, then I can easily find the point where image is formed, because other reflected ray will meet the same point. Okay, so and those reflected ray, the incident rays which come from one object. Okay, it is not like that I have two different objects and I can expect the reflected ray for those two different objects will meet at same point. No, for a corresponding object there will be many incident ray and the reflected ray will meet at one point. Okay. Now coming back to the main point, reflected see, they can two ray can meet at different points, but all those rays will meet at one point for sure. Okay. Now that means if I have two rays, okay, if I have two rays, okay, two reflected ray and find the intersection point. If I have two rays and find the intersection point, okay, then I can find the image. So that means at least I need to understand the reflected ray. I need to understand the path of this reflected ray. Okay, so there are well defined four cases. Okay, there are well defined four cases. Okay, and we can what are the reflected ray for those four cases, and to form the image we can have two reflected ray and we can find the intersection point. We can find the intersection point. Then that intersection point will be the reflected the point of image formation. Sometime back I said that all those reflected rays will meet at one point. That is for sure, remember. And it is not like that. I have by mistake said that two reflected rays meet at some other point, but all will meet at one point. No, all the reflected rays will meet at one point, and that point is the point of image formation. Remember, okay, there will be only one point when all the reflected rays will meet. That means if I have only if I can get the intersection point of two rays, okay, then I can get the intersection point of all the rays. Okay, if I can get the intersection point of two reflected rays, then I can get, suppose this is the point. Okay, these five reflected rays are meeting. Now if I have these two rays meeting at this point, then I don't need the other rays. Okay, I don't need the other rays. Okay, so out of these four cases, special cases defined here, I discuss. If I can have two reflected rays, then I can get the intersection point, and that is the point of image formation. So four cases we have considered. Okay, so if the incident light, is like out of these four cases, and what will be the corresponding reflected ray? The first one is if the incident light is parallel to the principal axis. These things we have already discussed. Okay, if the reflected light is parallel to the if the incident ray parallel to the principal axis, what will be the reflected ray? Second point, if the incident ray is passing through the focus, what will be the reflected ray? Third is if it is passing through the center of curvature, then what will be the reflected ray? And fourth is if it passes strike at the principal axis, what will be at the pole, then what will be the reflected ray? Okay, now we will discuss one by one. The first one is incident of parallel, that we have already discussed. Okay, so see, this is the incident ray parallel to the principal axis. This is one incident ray. Then there will be a reflected ray, right? Then there will be another incident ray Okay, that the point is, remember, we have already discussed the reflected ray correspond to the incident ray, which is parallel to the principal axis, will pass through the focus. That we have already discussed. Similarly, for convex mirror, it will diverge, but it will appear that it is coming from the focus. Okay, now this we have already discussed. Going back to the second point, and remember, the second point is the opposite of this. Here, the incident line is the parallel to the principal axis, the reflected ray is passing through the focus. Now, what if the incident ray pass through the focus, then what will be the reflected ray? This one. See, now the opposite case, the incident ray pass through the focus. Then remember, the opposite will happen the same thing. That means the reflected ray will be parallel. See. So the case 1 and case 2 are opposite to each other. The case 1 and case 2 are vice versa. Okay. So if that means if the incident ray is parallel to the principal axis, reflected ray will pass through the focus. If the incident ray pass through the focus, reflected ray will be parallel. Okay. Okay. Now similarly for the convex mirror. Okay. Let we have incident ray. Okay, directed towards the focus. That means this is the incident ray directed towards the focus, because this is the surface and this is the surface. Okay, light will be on this side. Okay, so light is coming from this side, which appears to be directed towards the focus. Then the reflected ray will be parallel to the principal axis. Now, the case 3. What if it passes through the center of curvature? Okay, remember, if it passes through the center of curvature, the reflected ray will travel in the same path but in opposite direction. Okay, that means it will opposite direction to the incident ray. Okay, that means the reflected ray will follow the same path. So in a concave mirror, light passing through the center of curvature, after reflection reflected back along the same direction. But in convex mirror, the same thing. The incident ray is directed towards the center of curvature, and the reflected light will follow the same. Okay, and next is pole. In the pole, when the light strike at the pole, see, this is the light strike at the pole, make it, okay, the reflected, this is the reflected light. Remember, this will make an angle. See, I will discuss why this is the this is angle theta I, suppose theta 1, and what is the angle here? Theta 2. Okay, so in a concave or convex mirror, a ray of light directed obliquely at the pole is reflected obliquely, making equal angle. Okay, it will be, let me tell you something. On the plane mirror, we have already discussed. In case of plane mirror, this is the incident ray, this is the reflected ray, and this is the normal. Sorry. This is the normal, and you remember this angle and this angle are equal. Okay, so the same thing is happening here. This is the surface. What will be the transient here? This is the transient to the plane. Okay, and then this is the normal to that plane. Okay, this is the transient. Okay, this is the normal. So this is nothing but the angle of incident, and this is the angle of reflection. Okay, that's why when the incident ray strikes at the pole, the reflected ray, okay, the reflected ray travels making an angle same as the angle made by the incident ray with the principal axis. The simplest thing you can do, the principal axis here work as the normal to the plane at the pole. Okay, so the principal axis, this principal axis work as the normal to the plane at this pole, and you know, if it is the normal to the plane, then this will be the your angle of incidence, and this will be your angle of reflection. So angle of incidence is equal to angle of reflection. That is the first law of reflection. The similar case for the convex mirror. Okay. So these are the questions. Define the principal focus on concave mirror. The radius of curvature of a spherical mirror is 20 cm. What is the focal length? These two questions you try to answer. And another question I am asking you. What are the differences between concave mirror and convex mirror? Okay. So these three questions you try to answer. I have not written. Okay. What are the differences between concave mirror and convex mirror? These three questions you try to answer, and if you find any problem, then write to me on question@srm@gmail.com. Okay, bye, and we'll meet in the next lecture. By the meantime, if you have any doubt, send me. I'll try to answer your question. Okay.